Or who?
Jewish. He does his fair bit of talking.
Yeah.
I would never.
Not you, ever. All right, so today, got some notes. We're gonna literally solve equations because there's two different kinds of equations. There's linear equations and then there's literal equations. So we're literally solving literal equations. And then we got some homework and we can get some stamps for those that didn't get stamps yesterday. All that fun stuff. All is well. So let us start on the retrieval. So 1, 2, and 3, they're asking you to do that mathematical operation to both sides and then see if it makes sense in the end. 4, 5, and 6 are find me the intercepts of them, x and y intercepts of all of those. Actually, 4 and 5 are that, and then 6 is a solve. Okay? I think for you, it is on 2 pages. So it is pages, is that 7 and 8? 8 and 9. Pages 8 and 9. Okay? Go for it. Give you a couple minutes to get those done. I guess I gotta use this one today. I don't know what happened to the other one. Somebody probably stole it. Whatever. Alright, so if I add 5 to both sides here, that means I would add 5 and add 5. And then I would get the 12 is greater than 2. Do we agree with that? Is that still a true statement? Yes. Alligator still eating the bigger number? Yes, so that would be a true statement, and that is true. Okay. Multiply both sides by 2. So if I multiply both sides by 2, I get negative 16 is less than 24. True or falsitude?
True.
That's a truth. That's a truthiness. Okay. Okay. Now let's divide by negative 2. When we divide by negative 2, we divide by negative 2, and I get negative 3 is less than negative 5. Is that true or is that false?
False.
That is false because it's negative, so that is a falsitude. And that is why whenever we multiply or divide by, multiply or divide an inequality, by a negative number, the how do I want to say it? Not the sign, the the inequality. Needs to flip. Okay? So that's one of those rules when we're multiplying or dividing by a negative number in an inequality. That inequality has to flip. And it's only with a negative. It's not with a positive, because we show that in number 2, that with a positive number we're fine. Okay? But if it's multiplying or dividing by a negative number, that inequality needs to flip. Okay? X-intercept is where y is equal to 0, so that would be negative 1, 0 for that one. Y-intercept is where x is equal to 0, so that would be 0, negative 4 for that one. Agree with me on that?
Yes.
Okay. X-intercept is where the line crosses the x-axis, which would be at 2, 0 for that one. Y-intercept is where the line crosses the y-axis. That would be at 0, negative 1 for that. Agree with me on that? Okay. Number 6 is a straight up solve the equation. What would you like to do first to solve said equation? Subtract x from both sides. That leaves me with 2x plus 6 equals 14. Then subtract 6 from both sides. Leaves me with 2x equals 8. Then divide 2, both sides, gets me x equals 4. 4 times 3 is 12. 12 plus 6 is 18. 4 plus 14 is 18. 18 is equal to 18. Questions on any of those? Okay. All right. So we're solving linear equations and we're solving literal equations. Okay. So here in number 1, which should be on the next page, here in number 1, there are 2 different kinds of equations. Now the left equation, 3x plus 2 all divided by 5 equals 7, that is a linear equation. Okay? Because there's one variable and there's one thing to solve for. It's got an exponent of 1. It's a linear equation. The problem with the right side looks very much the same, except this one down here on the right has both an x and a y in it. Okay? So that one is a literal equation, so we can't necessarily solve same steps, but we don't get a numerical answer for it. Okay? So here on the left one, we'll solve the linear equation first. What would you like to do first to solve this? Multiply both sides by 5. Love it. Thank you. So then that gives us 3x plus 2 equals 35, because those 5s cancel each other out. Love it. Next. Subtract 2. Okay. Those 2's then cancel each other out. Leaves me with 3x equals 33. Next. Again. Not divide by 11. Divide by 3 to get 11. Yep. I knew what you were saying. Just wanted you to say it right. Okay. All right. So then we get x equals 11. There. Okay. Now, if I'm solving the literal equation for x, first step, I'm going to multiply both sides by 5, just like we did in the linear equation, because that 5 is going to cancel each other out right there. So then that's going to be 3x plus 2y equals 35. Now what would I do then? I want to solve for x, which means I got to get x all by itself.
Get rid of 2y.
How am I going to get rid of the 2y? What's right in front of the 2y? No? In front. Adding, right? It's being added. So what's the opposite of adding? Subtracting. So I'm going to subtract 2y from both sides. Because that goes away. Can I combine this side? No, because those aren't like terms. So this is going to be 3x equals negative 2y plus 35. I would also accept there 35 minus 2y. With me on that? Okay. What would we do next to get x all by itself? Divide by 3. And I'm going to divide everywhere by 3. Not going to just do it in one spot on the right side. I'm going to do it everywhere by 3. So then that would give me x equals negative 2/3 y plus 35/3. Now, lots of you have been reaching for these semi-occasionally wonderful inventions. Okay? Right? On regular equations, we can use them to help, but we should be leaving our answer in fraction form. Right? Okay? Like on the boot camp, when it was the second answer was 11/5, everybody went to their calculator and did more work by typing in 11 divided by 5 and getting 2.2, when the answer could have just been 11/5. Okay? Here, in a literal equation where we've got multiple variables, we can't use the calculator at all. Okay? There's nothing that you can type into the calculator out of that literal equation. Okay? So start moving away from using the calculator for everything and start using this calculator in between your ears. Okay? You try now number 2, solving both number 2's for x. Walk me through it. Number 2, left one will go first. First thing. Where would I multiply by 3 on both sides? Everywhere? Ooh, then I don't like it. If I'm going to do that first, I got to multiply everything by 3. So I got to multiply by 3 here, I got to multiply by 3 here, and I got to multiply by 3 there. If I'm going to do that. Okay? Right? I can't just do it onto one part of one side. I got to do it to every part on both sides. Okay? All right? Anybody do it differently? Because I would have actually here, I would have added 5 first to both sides. Okay? And then I would have multiplied by 3, and then I would have divided by 4. Actually, I would have multiplied by 3/4, but that's just me. Okay? So if I multiply everything by 3 then it's 4x minus 15 equals 33. Then add 15. Then divide by 4. Me, I would have done added 5 first, gotten 4/3 x equals 16, and then I would have multiplied by 3/4. Because dividing by 4/3 is the same as multiplying by 3/4 after we keep change flip. Okay? Because the 3 on the top cancels out the 3 on the bottom, and the 4 on the bottom cancels out the 4 on the top, leaving me just with x. 16 divided by 4 is 4 times 3 is 12. So we get x equals 12 there. So that should have been. Okay. What would you do first on the right equation? Multiply by 3 everywhere. Okay, that's fine. We can do that. Then we would get 4x minus 15y equals 33. Then what? Now add 15y. Y plus 33. Then divide everywhere by 4. X is going to be 15/4 y plus 33/4. You've heard me say this before, and you'll hear me say this again. The sooner you embrace fractions and embrace improper fractions, the faster you'll catch on to mathematical concepts, and the easier math will become for you. Okay? Okay?
Okay, why for like these ones you have to multiply everything like by 3, but then like
Because the 5 is part of the 5.
So because the 5 here is still on that side. So I'm really multiplying. So really what I'm doing by multiplying every term by 3, I am taking 4/3 x minus 5, and I am multiplying that side by 3. Right?
so like because that -5 is there, that's why
Yep. Okay. Because so like before, let me scroll back up a little bit. Before, when we multiplied here both sides by 5, we multiplied the side by 5. So really we multiplied the side by 5. Right? Okay? So now if I scroll down here and I multiply the side by 5, I have to distribute that 3 now into both of those terms. So I'm really multiplying every term by 3. Okay? Good question. Try number 3. I'm going to start out by multiplying both sides by 5/2. Okay? 5/2 is the reciprocal of 2/5. Multiply both sides by that. On the left side, I just get x plus 3. On the right side, I get 6 times 5, which is 30, divided by 2, which is 15. Then I can subtract 3. And x is 12. Oops. And x is 12. Okay? You could definitely distribute in the 2/5. Get 2/5 x plus 6/5 equals 6. Then you got to subtract 6/5 from both sides. So now you're talking about subtracting fractions, so you need a common denominator. And then multiplying by 5, dividing by 2. Okay. Likewise here on this side, I would again multiply by 5/2. That leaves me with x plus y equaling 15. Then I can subtract subtract y. And x would equal 15 minus y. Questions, comments, concerns, clarifications? Try number 4. I got x equals 2 for the first one. Yes? Okay. I don't know why I put minus 4y there. That should be plus 4y. There we go. Trying to figure out how it got negative. X is going to equal 2y. Is what I get for that one. Yes? Concur? Okay. Let's do number 5 together. We'll do 5 and 6 together, actually. We still want to solve for x. So I want to get x all by itself. So what would I do now in number 5? Kim? Multiply both sides by c. Yep. So my left side becomes what? X plus b. And what is my right side? D times c or cd. CD or DC, either one. Doesn't matter because multiplication is interchangeable. What's next? Cam?
Minus b from both sides.
Minus b from both sides, yep. So that leaves me with x equals CD minus b. Agree? Alrighty. Let's do number 6. 6 scares you a little bit?
Yeah.
Okay. A little intimidating? What do you want to do first? What do you want to do? That would give me, if I multiplied by 2 on both sides, I would get 2 square roots of x over n equals 2t. So I don't want to multiply by 2 on both sides. What gets rid of a square root? No. No. There already is a square root. What? So what do we call it when we multiply it by itself? It is an S word. That's a good S word. It's my second favorite S word. We get guys? Square it, right? We're going to square both sides. Yep. Okay. So we're going to square both sides because a square is the opposite of a square root. Okay. So that means the square root goes away. So this just becomes x over n. T squared is, no, not 2t. I'll say it again slower this time. T squared is what? Is t squared. It was a trick question. I know, the meanest. Still when I solve for n, multiply both sides by n. I think I said we gotta solve for n, but we gotta solve for x. X is equal to t squared times n, or nt squared. Okay. On the next page, we got some filling in the stuff to do. Now, truth be told, I will flat out tell you this right now. I don't think there's not so much that you're never going to use it. You're going to use this stuff a lot, okay? But I'm not going to specifically ask you what is the commutative property in addition, okay? And have you give me that a plus b is equal to b plus a. Okay? I just want you to know that order doesn't matter with addition. A plus b is b plus a. Okay? That's what I want you to know. I don't necessarily care that you know the names of these all, with the exception of the distributive property, because you're going to use the distributive property a lot in the next 4 years. Okay? Give you a couple of minutes to write this down. So your homework this evening is pages 8 through 11 in the blue packet, numbers 1 through 21. Let's take a peek at it. This is for 2s. This is for 3. So number 1 is kind of doing what we did in the retrieval at first. So subtract 7 from both sides on that one. Okay. Looking at those again. Three, 4, 5, 6 are all solving for a specific variable. 7 and 8, and 9 and 10 are all still solving for a specific variable. Okay. X and Y intercepts from a table. Guessing the next one is going to be X and Y intercepts from a graph. Yep. And then solving the equations for X. All stuff we did today.